Hi, my name is NURSYAKILAH binti LAHANING. So today I would like to teach you on how to transform simple acetylene into pentanal, which is a 5-carbon aldehyde. The first step is alkylation, which is crucial for building the carbon chain. We deprotonate acetylene to create an acetylite ion, a strong nucleophile. This then attacks one bromopropane, effectively extending our 2-carbon chain to 5 carbons, which is resulting in 1 pentene. The second step is converting that terminal alkyne to an aldehyde using hydroboration oxidation. This specific reaction ensures an anti-Markovnikov addition of water across the triple bond. The resulting unstable enol quickly undergoes tautomerization to yield our final stable product, which is pentanal. In summary, through efficient chain elongation and targeted hydration chemistry, we successfully synthesized pentanal from acetylene using just 2 distinct reaction types.
We can see it's ester. You have got a carbon double bonded oxygen and single bond to an ether. So that's an ester, and it's remarkable that you can take benzene, the vapors of gasoline. We can see that the connection between nucleophilic substitution, the nucleophile that has to come in the leaving group that would leave. We can think in how we can turn benzene into the nucleophile. Then we can do Friedel-Crafts alkylation. We can use CH3Cl. Here's our 1 carbon that we are adding and put AlCl3. Next, we can do Friedel-Crafts alkylation that would put the methyl group on the benzene ring. Once you have that, you can sort this in many ways like oxidation. So you can use strong oxidation agents such as A2CO3, H2O, and H2SO4. Then we bring to carboxylic acid of benzoic acid. You can reduce it a strong reducing agent like LiAH4, followed by water to do the proton transfer to stabilize the charge, and that would give you your alcohol. So once you have this alcohol, we can just react it as nucleophile to replace the chlorine in this ethanol chloride. So we have that whichever one of those you use, if you treat with this ethanol chloride, you will replace the Cl to put some pyridine in here. The lone pairs can act as the base, then steal the H off. What you get is your nucleophile replacing the chlorine leaving group. So you would have the oxygen and then the double bond to oxygen and the carbon. So this is our benzyl acetate.
Hi, my name is SITI KHADIJAH binti ANUAR, and I would like to identify the structure of compound A to E below. Okay, this was benzene. Benzene was the starting material, and then when benzene go to the compound A, it was Br2 FeBr3, and it will be electrophilic aromatic substitution. So they will reagent and will replace a hydrogen with a bromine. Then the final product is called bromobenzene. Compound A was a bromobenzene, and the B it's made magnesium. It's stronger than bromine, so the bromine will easily separated, and it's called reagent of Grignard. And it's turned out the final product will be phenol magnesium bromide. Next, we go to the compound C, right? And then when they have a O on the aldehyde, it will turn out to be nucleophilic addition. This is because O was an alcohol, and then it will follow by acidic workout, which is H2O plus, and it will form a primary alcohol. Then the final product will be benzyl alcohol. PCC was an oxidation process, so it was an oxidation of primary alcohol using PCC. PCC is a pyridium chlorochloromate. So this PCC will convert the alcohol to aldehyde, and then the final product will be benzaldehyde. Okay, then we go to the last step is benzaldehyde was a compound D to the compound E. Okay, the compound E, as we know, it was turned out to be acetal formation. So it will reagent with ethyl glycol, which is HO, CH2, CH2, and negative OH. Then it will acid catalytic is H plus with water removal is a negative H2O, and it will protect the aldehyde. Then it's turned out to be, so the name was 2-phenyl 1,3-diazolene.
This poster shows an effect synthesis for the Gibbs transformation. First, methyl-cyclohexyl react with bromine and aldehyde to add the bromine atom, the KOH and HADR using element hydrogen, bromine with bromine and from an alkane. Next, This makes the alkane undergoes oxygenalysis with O3 followed by H2O2 which break the double bonds and form carbonyl compounds. After that, NABH4 is used to react the carbonyl group into diol. The diol then react with PBr3, converting the hydroxyl groups into bromine atoms. Finally, excess dimethylene replaces the bromine atoms to form the tertiary product. These questions show how defect reactions are used step by step to reach the final compounds. That's all from me. Thank you.